So we were looking at geometric mean in the previous lesson, and so now we're going to look at the worksheet that we started in class yesterday, or this morning, sorry. We started this morning, and we'll work on it again tomorrow in class. But we started it this morning. I think I only got through number 1 and number 2, so let's see what we can do here. We've got a right triangle. Now what you need to remember about the triangles is when we have geometric mean. So I'm going to come here. First thing we're going to do is we're going to look at geometric mean as it applies to a right triangle. So when I draw a right triangle, this is a right triangle, okay? Wow, that's pretty, I know, I'm really artistic. No applause, please. So I've got my right triangle right here, right? Okay, so I've got A, B, and C are my 3 triangles. Let me zoom out a little bit again so that you can see a little bit better. There we go. Okay, so you should be able to see them. I've got A, B, and C. If in a right triangle there are 3 altitudes, okay? Altitudes meaning vertex to opposite side at 90. Well, what do we know about a right triangle specifically? 2 of the altitudes are already there because they're already creating a right angle. Side BA, the leg, is already an altitude. It goes from vertex B to side AC at 90 degrees. Leg AC is also an altitude because it goes from vertex C to side AB at a right angle. So in a right triangle, we can only really theoretically draw one more that's not already there, and that's this one here, and I'll call that AD. Okay, so that's our altitude. Now, how do we use geometric mean with right triangles? Well, we did a similarity exercise in class with the patty paper. And remember, what we did was we took the 3 triangles and we traced them, and we took them out and put them side by side. And I'm going to start with the smallest triangle here. So we had triangle number 1, which was our small triangle. And that was this one, ADC. That was triangle ADC. Then we had our second triangle. I'm going to call that triangle 1, which was our medium-sized triangle. That's this one. Okay. And that's triangle 2. And that was triangle BDA. And then we had our last triangle, which was our largest one, which is the big one here. And that's triangle BAC. Okay, so I've got triangle 1, triangle 2, triangle 3. We did a lot of similarity exercises with these. Because remember, similar figures have congruent angles and proportional sides. Okay, that's important. They have congruent angles. Hopefully you can see that. They have congruent angles and proportional sides. So the angles will match up, but the sides will not be the same. The angles will be congruent, but the sides actually just have the same ratios. So look at the picture here. I've taken these 3 triangles apart and I've created 3 similar triangles. So if I look at my ratios of the sides of these triangles, I know that side AD is proportional, okay, with side BD, and that's proportional with side BA. Okay, so let's look at the next relationship. I've got CD, or DC, is proportional with DA, which is proportional with AC. Okay, these should all be giving me equal ratios. And the last one is AC is proportional to BA, which is proportional to BC. So these are all my proportional sides. These are all proportional, these are all proportional, these are all proportional. Okay? If I were to take this triangle and rotate them and stack them on top of the big one, this is what you would see. The small triangle would fit right here. Okay, the small triangle would fit right there. The medium triangle would fit right here. And then of course the big triangle is here. They're all similar. All of their angles match. You remember corresponding angles? That one, and that one are all the same, right? That one, and that one are all the same. And then what angle do they all share? They all have this one, right? Do you see how all three triangles have the same angles? Exact same angles, okay? So three triangles have the exact same angles, so they're going to be similar, okay? Now, with that similarity being proven, what we know about this altitude, I'm going to call this altitude x. The altitude is the geometric mean of this piece and this piece. So it's going to be the geometric mean of those two, which means, for example, let's say this is 3 and this is the whole thing. We'll say that that piece is 3 and we'll say the whole thing is 30, okay? Which means that this piece, how would I find this piece? Well, if the whole thing's 30 and that's 3, that means this is 27, right? Okay? So if that's 3 and that's 27, how do I find the altitude? I use the geometric mean. That's the shortcut. 3 over the altitude, this piece over this one. And what is this piece actually representing? This side of the small triangle, right? Isn't that what the 3 represents? Okay. X is the altitude. Okay, oops. That's 3, my bad. That's the 3. X is AD. So this is X and this is X, right? It's the other side of the small triangle and the smaller side of the medium. It's the big side of the small one and the small side of the medium, right? And then you've got 27. What does 27 represent? Well, do you see triangle 2 here? 27 is this piece, BD. Now, I know these are all similar, right? Because I know these are similar, that's why I can use geometric mean here. 27 over what? X should equal, because these are all similar, they're the same ratio, right? X over 3. 27 over X should equal X over 3. So now I'm going to cross multiply. So 3 times 27 is 81. X times X is X squared, not 2X like we were all saying this morning. That's okay, that's why we do this, to learn. And then to find X, I take the square root of both sides and I get X is equal to 9. So what that means is the small side of the medium triangle is 9, and which is also the large side of the small triangle. That's also 9. Okay, or sorry, the altitude is 9, using the ratio of the small side of the small triangle and the big side of the medium triangle. That is your geometric mean. So anytime you have a right triangle, this piece over this equals this over this when you have an altitude in a right triangle. And that's how you can use geometric mean, okay? So that's how you use geometric mean. Now, let's go back to our assignment. We've got our assignment here that we got this morning. And so when we're looking at this, let's look at this particular triangle. What I have here, and let me zoom in a little bit. Okay, what I have here, I have 36, 100, and x. And we did this one in class. Everybody except for 5th period. We didn't get to it 5th period. So according to what I just worked out, this piece, x, is the geometric mean of that piece and that piece. And I'm going to circle this in red, okay? So that's the geometric mean, which means 36 over my altitude, which is x, equals my altitude, x, over, and if the whole thing is 100 and that's 36, then what does that mean the other piece is? 64. Okay? This over this equals this over this, or vice versa. That's how you use the geometric mean with the altitude. Now I'm going to cross multiply these guys. So I get x squared equals 2,304. Okay? 2,304. When I take the square root of both sides, I get 48. So your altitude is 48. Your altitude is also what? It's also the bigger side of your little triangle and the smaller side of your medium triangle. You have to be able to separate those triangles out. That's a big part of it. Okay, let's look at the second one. Okay, we did the second one also in class. So let's look at the second one, and I've got 9 right here, and I've also got the whole thing is 25. So what's this piece? 16. All right, so I'm looking for this. There's different ways you can find this. I'm going to use geometric mean here. You can also use similarity, okay? I'm going to do geometric mean first, then I'm going to do similarity. All right, let's do geometric mean first. So let's find our altitude first. Let's call that y. This is x, so let's call that y. 16 over y, or it doesn't matter. I'll put 9 over y just to keep it consistent, the smaller length, but it doesn't have to be that way, equals y over 16, because y is the geometric mean. So I'm going to cross multiply these guys. Okay, and I'm going to end up with y squared equals 144. So at that point, what I'm going to do now is I'm going to take the square root of both sides, so y is 12. Okay, y is 12. Now 12 represents this. Do you see that little bitty right triangle right there? If I were to pull that triangle out, what you would see is 12 is here, 9 is here, and we're looking for x. That's Pythagorean theorem. A squared plus b squared equals c squared. So I got 144 plus 81 equals x squared, which is 225 equals x squared. And when you take the square root of 225, you get 15. So x is 15. We weren't looking for the altitude here. We were just looking for x. Now, if you want to use similar figures, you see the tiny triangle right here? Okay? Let's say I didn't know the 12. Let's start over again. And let's say that we know x is here, and we know that 9 is here. What's the other triangle here that has x and 9? The big one, right? See the big triangle here? The little one has x, and so does the big one. So if I bring the big one out, where's the x? It's at the bottom, right? And how long's the hypotenuse? 25. So now I can just do a simple ratio. I can say 25 over x should equal x over 9. And then that's geometric mean. The x is the geometric mean, so I get x squared. Okay, x squared equals 225. And when I take the square root, x equals 15. Same answer. Similarity here, geometric mean and Pythagorean theorem here. Doesn't matter how you solve it, okay? We're running a little low on time here, so I'm going to skip and we're going to do a couple more examples, but I'll do that in the next video.